Okay, good morning everybody. So I'm not there. I'm just got a doctor's appointment and I'm not feeling very well, so we'll see. Anyway, first thing I want to do is take a look at your journal on page 165. Okay, this is page 165. It talks about exponential growth. So growth, like the Skittles, it's going up. And what we know is the base has to be greater than 1. Base must be greater than 1. So it's like doubling or tripling. Exponential decay, it's going to go down. It's getting smaller and smaller and smaller. And we know that if it's decay, that the base is going to be less 1, like 1/2 or 1/3. It's like a base of 2. It's like a base of 1/2, okay? So compounded interest is something we're going to also talk about. Compounded interest is an exponential function. So if you put money in the bank, let's say $1,000, it's going to grow. And as it grows exponentially because the interest you make, let's say you made you make $10, so that means you got now $1,010. Well, you're going to make money on your interest, and then you're going to make money on that. So this will be, and we're going to look at this later. That is going to be in our notes, okay? So, exponential growth functions, we can rewrite it like this. 1 plus r. Now, r is our rate to the t power, okay? Our rate is going to be like 8% if it's banking, or 12%, okay? And that graph we know looks like this. It's growth. Your money's growing. And then if I look on the next page, it's decay. For example, this crummy cold I have, I'm hoping that the darn virus in me is starting to decay, okay? If this number could be like, hopefully my cold's getting over and the exponential function's getting smaller and smaller and smaller, and so that would be decay, all right? Here is our formula for banking. We will look at this in our notes. P is what we invest, our principal. You have to have the 1. R is your interest rate in terms of a decimal, like for instance if it's like 6%, example, we'll change that to 0.06. N is the number of times you compound, like it's quarterly, it's 4, semi-annually it's 2, it's monthly, it's 12, and T is time in terms of years. We'll look at this one in our notes, okay? So now hopefully every note's passed out, and let's take a look at these, okay? All right, here we go. Today's date is November 16th. Our objective today is to look at exponential functions with growth and decay. I'll give you a second to write that down. All right? Exponential functions with growth and decay. And I gave you a formula. Okay? So here's our formula, okay? We want to keep this formula here in our notes. If it's plus r, it's growth, because we're adding, whoops. If it's subtract r, then it's decay. All right, example 1. The inaugural event of a new band at a concert was 150,000, okay? Each year the attendance increased by 8%. So this band's getting big, right? It's getting super popular. Write an exponential function. Now we know it's growth. So let's look at this equation here. Okay? All right, f of x equals a. A is our beginning amount. A is 150,000. So look at this equation. A, 150,000 parentheses. 1 plus r is our growth rate. R is 8%. But we'll change that to a decimal, right? 1, 2, or it's going to be a 0.08. I'll put that right there for r, 0.08 to the x, okay? And we can even change it in terms of years, okay? So x would be years. So now using your equation, find the estimated population of 4 years. Okay, so I'm going to use this formula and my calculator. I'm going to go, okay, f of 4 okay, because I'm plugging in 4. So 150,000, 1 plus 0.08 to the 4th power. And again, I had a calculator. I like my good calculators. You guys can use your, your phones don't really work very well. I'd rather have you use my calculators. So I'm going to go 150,000. Parentheses, type it in just like it is. 1 plus 0.08 to the 4th power. And I get an answer of 204,073 people. I'm not going to put 0.3 because that's silly, right? People that are going to attend my concert. Okay, that's growth. Example 2. The scientist starts with 100 grams of radioactive elements that decays. Okay, it's decay. So it's decay. I'm going to use that formula. Okay, decays at a rate of 3% per day. Write an exponential function to model this. So I'm going to use this one here. Decay. I'm going to go f of x equals A is the beginning amount, which is 100. Use my formula 1 minus. Now minus my percentage, my R is 3%, but I'll change that to a decimal, right? I'll move the decimal 2 places. 0.03, I'll put that there, to the x, right? So I just used my formula. Okay, I'm going to put it in there. So now I have an equation. Let's use it for after 10 days. Now this is per day, so 10 days I'll put in 10. F of 10 is equal to my 100 times 1 minus 0.03 to the 10 power. Okay, and I'm going to use my calculator then. And I like mine. Mine are nice calculators to use. I'm going to go 100 parentheses, just like it says, 1 minus 0.03 to the power of 10, and I get an answer of about 73.74. And I can, because it's in grams, I'm just going to go 73.74 grams. Okay. All right, so just using the two formulas, growth is to add your rate, decay is to minus rate. So I'm just using my two formulas, okay? You ready to turn the page? All right, turn on the page. Okay, determine if these functions are exponential growth or decay. Well, if this base here is less than 1, it's like taking 87% of it. So this one's definitely got to be decay, because on the front I said if the growth, I talked about it in the journal, if the growth is, if the base is less than 1, so if my base is less than 1, it's got to be decay. All right? B, 5/4, the base is greater than 1. So it's like multiplying by 5/4, it continues to grow, 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 grow. So this one's got to be growth. C, our beginning amount is invisible 1, but our base is 7/8, so which is less than 1, so it must be decay. So if the base is less than 1, you take 7/8 of something. 7/8 of something is going to make it less, so it's going to get smaller. Okay. Example 4. Well, if I take a look at example 4, shoot, looks linear to me. I go up by 5. Oh, maybe not. Up by 10. Up by 20. It seems as if I'm doubling, doesn't it? Okay, up by 1. So I must be doubling. So my equation would probably be y equals, let's say I started with 5. Remember our y equals a b to the x equation. We learned that yesterday. We learned that with the Skittles too. Beginning amount is 5. My rate, I'm doubling to the x power. There's my equation. Right? Definitely exponential growth. Okay, now if I look at number 2, this example, let's see. Looks like I'm taking a third of it. 1/3 of it. A third of that. And a third of that. So definitely that one's decay. I'm going to use this equation here. Okay. This equation here is going to be, let's see, y equals, my beginning amount was 270. My rate is 1/3 to the x power. Okay. And finally, our banking. And I will go through this slowly. You will need a good calculator. Okay. Let's go through this. Okay. $12,000 is invested in 2 different banks for 5 years. Okay. Bank A compounds amount quarterly. Quarterly is N. Okay, I'm going to write this down. N equals 4. N equals 4. Quarterly. Quarterly. 4 times a year. I compound my money. Put it in there, and then every 3 months they give me some more money. Okay? Quarterly. Bank B, monthly. So my N is 12. Okay? I know T is 5 for 5 years. My interest rate on Bank A is 0.025. And my interest rate on Bank B is 0.024. Okay? I want to use this formula. How do I use this formula? Well, let's do Bank A first. I'll go slowly. Bank A. A of T. All right? A of T equals P. Well, P is what I'm going to put in. P is 1,200. This is my P. That's what I call it a principal. 12,000 parentheses, just like the formula says, 1 plus. Now the R is not 2.5, but we have to change to a decimal. 0.025 divided by N. N is 4 for quarterly. To the power of N, which is 4 times T, and T is 5. Okay, write that down. There's Bank A. And I'm just going to use my calculator to find out how much money I have in the bank after 5 years. So in my calculator, and I like my nice calculator, so I'm going to go just type it in. 12,000 parentheses 1 plus 0.025 divided by 4 to the 4 times 5 power, or to the 20th power. Okay? Alright, here's how much money I have in the bank. So I made some. Okay, after 5 years, now I have $13,592.49. Okay, try that on the calculator. Make sure you can get those answers. Okay, try it on the calculator. Make sure you type it in correctly. I'll put it that way so you can see it. Okay. All right, let's look at Bank B. Okay, Bank B. Same formula, but N is 12 and my interest rate is 2.4. So again, I'm going to invest using the formula. I'm going to invest. P is my principal. I'm going to invest $12,000. 1 plus my R, which is not 2.4 but 0.024. I have to change it to a decimal. 0.024 divided by N. Now N, you're going to do it monthly. So N is 12. To the power of, okay, N is 12 because it's monthly, number times up per year. And I'm going to keep it in there for 5 years. Okay, so there's my formula. It's all set up. I'm going to plug this in. I'm going to take my good calculator, go 12,000, parentheses, whoops, clear that, 12,000, parentheses, I'm going to go 1 plus 0.024 divided by 12 to the power of, well, 12 times 5, or 60. Okay, and about almost the same amount of money, right? I get $13,528.34. Okay, it's interesting. You compounded this one more often, but you made less money. So it's all about the interest rate. Your parents will tell you that for sure. It's all about the interest rates. Okay, so homework. what I have for you is page 106. So homework is page 167. And I'd like you to do 1 through 10 all, okay? Get that done, and hopefully I'll see you tomorrow, okay? All right, bye.